All right, welcome everybody to the July stream for the Leptos monthly meetup. We have a very, very special show for you this month. I personally am super stoked to be here for this. We've got an awesome guest, Luca Palmieri, and he is the creator of Pavex, and he and Ben have been recently working on doing a Leptos Pavex integration, which is super exciting. And that is primarily going to be what this month's meetup primarily focuses around. We've also got a few updates as well. But we're going to kind of this monthly meetup is going to be a little bit different. We're gonna mostly focus on the Pavex integration, and this is going to be mostly a conversation between Ben and Luca. So I would encourage anybody with questions. I will be monitoring the questions both in our Discord chat as well as the YouTube chat. So I'll be curating the questions and be happy to pass those off. And in that being said, also don't forget to give the stream a like, and also be sure to join our Discord. I will put the link in the chat now. So without further ado, I'll go ahead and pass it to you, Ben, and we can get started.
Great. Thanks again, Luke, for setting this up. For those who haven't been here before, Luke's been kind of the driving force of this meetup over the last half year, however many times we've done this before. But he deserves a lot of credit for this. For those who don't know, my name is Ben Wisovich. I am one of the primary Leptos maintainers, the other one being Greg Johnston, who is on vacation, and well-deserved vacation, so we won't be here today. But we're going to be talking to Luca up here. If you
hello.
Say hi, Luca.
Hello, everyone. It's a pleasure to be here. Quick intro probably on my side as well. Name is Luca Palmieri. Been doing Rust for a few years at this point, probably 6, maybe 7. And I am the maintainer, creator, all the things of Pavex, which is a web framework that's been in the development phase for a year or so. And we're going to assume more of it as we go through demos and stuff. Generally speaking, I'm also the author of a bunch of other crates that you may have used, and the author of Zero to Production Rust, which is a book on backend development with Rust. That sums it up, more or less.
I mean, it's always been fun for me because the way I got into Rust, and especially Rust on the web, is Luca's book, Rust in Production. So I'm thrilled to have met him and to have him on here to talk about his new project. So very excited. Very excited. Nice. Before we dive into that, general updates. There is a new beta for Leptos 0.7, which we released, I want to say, a couple days ago. Please check that out and test it and tell us all the things we've done wrong. I'm sure there's plenty of them. And there's some neat updates to that as well. You know, we're going to have smaller bundle sizes, faster performance, nicer sync await handling. We've done other meetups on most of those features, but check that out if you're interested. So Luca, I've heard that you are developing a new web server called Pavex. Why are you doing that?
It's a long story and a short story. I'll give the short one first. I've been doing Rust on the backend for 4 or 5 years, more or less, at various companies, various places, different projects. And I think that Rust on the backend is viable. It's a very good stack in general. It's robust. You can do most of the things you want to do. But I've seen over and over again people struggling, A, to get started, and B, to succeed in some cases, actually get productive using this stack. And this productivity bump, like this failure to kick the tires and actually produce something of value in a short time frame, different people have different explanation. In my case, I think it's mostly due to frameworks that are a bit too small in scope. So what I usually call micro frameworks, as well as perhaps leaning too much into the type system and therefore requiring a level of Rust knowledge that is too high when people get started. The typical trajectory of a user might have heard of Rust, might have seen Rust on the Tech and Power benchmarks, they might have seen Rust because somebody told him it was blazingly fast, which is at this point meme-like. And then, they install Rust, they say, I'm good enough, I'm going to pick up the language on the way, pick Axiom or ArcticX Web, it doesn't really matter too much. And then they get their first really complicated type error, the ones that are like 6, 7 lines long, best case scenario, probably a full page on the terminal. And it says a lot of things and uses a lot of words. And most of those words I've never seen before. Some of those words are not even in their code base. And they're like, I don't quite know what to do. And then, the road bifurcates. Some people take the time to learn Rust beforehand. And so they kind of work their way through. Perhaps they have a mentor who explains to them how to navigate things. Perhaps they're just, they care enough. Like they have a very good reason to use Rust on that project, or they really want to learn the technology. They power through. They understand how the stuff works. Eventually, they get productive and things go on.
Okay.
But, it's not ideal. Be nice if you pick it up, started, more or less things worked. So that's why I started the project. So I tried to solve some of these problems.
So Pavex is correct me if I'm wrong here, a backend Rust web server that tries to be more batteries included than Axiom or ArcticX.
I would say it's a Rust backend framework. The server is mostly Hyper, so that doesn't actually differentiate things too much compared to the rest of the batch. Mostly because at this point, it doesn't make sense to invest the effort into writing a new server. I don't think there's anything fundamentally wrong with Hyper. Works really well. It's really fast. So it's really like about what goes above that layer. That's where the conversation starts.
Okay. Developing a web framework, especially, that sounds difficult. What do you think has been the biggest challenge writing, Pavex in general?
Oh, I think there's two main challenges. So challenge number one is that once you say you're going to do something big, such as a backend framework, and you're going to do something new, so you're going to use an approach that is different from the existing frameworks. Like you got to justify your existence in a way, right? Like right. Why am I doing this? Like why am I putting some effort into this? You take the time to rethink all the things. Like if you've been following the development of Pavex over the past year, you might have seen that I released, for example, a new cookie crate. To just quote one, there's going to be a new configuration crate at a certain point. Just taking the time to go through all the core things and asking yourself the question, can we do better than what's been done before? Which obviously dilates, the timelines of things. But it's also very nice as an opportunity to go deep on all the different parts of a framework. The second challenge is that due to the way the Pavex works, or due to the way I wanted Pavex to work, so I wanted dependency injection, I wanted minimal usage of generics, and a bunch of other things that we'll see probably later. I needed to develop compile time reflection, or a version of compile time reflection for Pavex, which Rust does not support out of the box. This required integration with Rust.json, which is an unstable feature, as well as the development of a whole, kind of reflection engine. You give me a function, I need to understand where does it come from? What are the inputs? What are the outputs? What can the outputs do? What do the inputs do? There's a bunch of graph analysis to understand if this dependency injection is going to succeed in compile time, and then to generate the code that's going to make it happen, which is basically a compiler. I call it a transpiler. And I'm a backend dev, not a compiler engineer. So that was quite the unusual project to pick up. I had to learn a lot of new things along the way. I'm sure things could be done a lot better. There's still a lot of bugs, but I think that definitely was a challenge. It's not something I'm used to necessarily.
It's funny that you say that you kind of have to prove yourself, because Pavex has a particularly unique kind of model for pricing, because it's not actually, well, I guess you can debate whether it's open source or not, but you've kind of got a unique planned monetization system for it.
Yeah.
Can you tell us a little bit about that and your thinking behind that?
Yeah, sure thing. Let's start a few steps back, right? When you start a project, you eventually want the project to become popular, like most of the times. Like if you're doing open source in the open, either you're doing something for yourself and it's like, yeah, this world, go use it, I don't care. Or you're doing it because you think there's a hole in the ecosystem, there's a gap that needs to be filled, there's a need that needs to be met. And sometimes you are lucky and you meet that need, which means a lot more people come and use your project, which means that the demands on your time and on the projects are going to grow exponentially. And I've seen time and time again projects become popular and then kind of crumble under the weight of that popularity because just there's not enough maintainer time. There's not enough maintainers. It's not easy to scale maintainers. Not everybody wants to scale maintainers, because that basically means becoming a manager of a bunch of maintainers, which is a very different job from being the author of a crate or a library or whatever. And so since Pavex is a large project, any backend framework is a large project. Like requires a lot of upfront effort to get something that kind of self-sustain. And then you also want to keep being, up to speed, develop whatever is cool at that point in time and making sure the framework grows. To do that, you need time. And time means time that's, subtracted from other things, subtracting from work, subtracted from, your free time, subtracted from everything else. So the idea for Pavex was we want this to be open source. So it is open source according to the Aussie definition of open source, as in the code is on GitHub and it is Apache 2 licensed. So you can go there and fork it. That's fine. But if you want to use it as is, so you want to take the binaries that we pre-built, you want to join the Discord server, you want to get any kind of support from me or other maintainers, we require a monthly fee, like a subscription that you got to pay whenever you're using the framework and the tooling that comes with the framework. Which makes it so that then we can actually dedicate some time to things. Now, all of these obviously are plans insofar as at the moment we are in beta, closed beta. So we don't charge anyone for anything because things don't work. There's some breaking changes, things are somewhat fluid. But the idea is once this goes in GA, so past the open beta, the actual official release, this will be a requirement. And that's fundamentally because we can try to offer things for free, but the pool of time that a person can dedicate to a project is finite. And so if you want more people to put more time into a project, eventually someone has to pay for it. Now, one approach is this. Other approaches are somehow we'll figure it out. And then there's the, we hope Microsoft likes us and gives us some money eventually. And the fourth one is we're going to do some kind of SaaS that sells on top of, we're going to do some type of open core model. So I've tried a fourth way, third way, depending on how you count them. We'll see if it succeeds or not.
I mean, I could talk about open source monetization schemes for a while, right? I mean, we've certainly seen a lot of different approaches in the web, in the web community, from getting bought by a giant company to starting your own thing alongside it to just doing it on the side. I mean, as a Leptos maintainer personally, me and Greg both have other jobs and we both do it completely for free part-time. But if we didn't have, we're all time limited and we all would love to do it more, but it's interesting to kind of approach that because not too many things have chosen that model. I think the closest that comes to mind was early days of Remix when they charged you like $300 a license or something.
Steep.
Yeah, maybe it was. How were you inspired by any other project with this model, or did you just kind of? Where did this come from?
There's a lot of very interesting material if you start to scour the internet for like open source. Well, let's put it different. If you start to scour the internet for business models first, and second, which are somewhat compatible with keeping most of your source code open source. I think a very large part of my thinking was also shaped by the CEO System Initiative. We used to be the CEO of Chef, He's done a lot of podcasts, he's written a lot about what open source is, what kind of business models can support, but also what are the drawbacks of open core and a variety of other kind of approaches to this. I'm seeing what they are doing, which is actually very, very similar to what Pavex is doing. Obviously, in their case, System Initiative is a cloud infrastructure management tool, kind of like Pulumi, but more like Figma. That doesn't make sense, it's fine. Just go check the webpage, make more sense. But fundamentally, they have a natural like SaaS offering. And so it's easier to say, this is easier to monetize. People are somewhat wired up to pay for things that they can use in the browser. When you look at tools like libraries and binaries and CLIs, it's a little bit harder, but I think the fundamentals are the same. Like people understand, or I hope they do, understand the fact that there's value in being supported by the official maintainers. They understand that the official maintainers have skill sets and expertise that is difficult to get elsewhere. And that fundamentally, if you're using a tool seriously and like in production at scale, there's absolute value in being able to get paid support that comes with SLA, support that comes with quality and time guarantees. So all of this obviously is theoretical up to an extent, but I think it's interesting. I was also aware of Remix, like I knew that this was the model in the early days, but then they got acquired by Shopify, so we never actually saw it playing out, if you want, until the very end. So I have no idea what their financials were like. I have no idea what things were like. So it's difficult to say I follow their approach mostly because I don't know if it worked or not for them. There's also a very nice talk, which I generally recommend, that I might try to Google at a certain point and then share it in the chat, from the creator of Elm, around maintenance and how to get money and the different incentives, the different funding models actually push you towards.
For sure. I mean, I love that talk too. If we could find that and put that in the links, that would be great. I mean, it's an interesting question, right? I certainly don't oppose the model and the idea that you pay for maintainers' time and support. I do kind of have to wonder where we draw the line. Like, do you have to pay for all of the parts of your stack and all of the dependencies? And like, I don't know if that's sustainable as an ecosystem, but I can admire you trying it out for your particular project for sure.
So I found the link to the talk. Yes. So let me just push it down there. The talk from Even. Nice. That was easier than expected. What do I want to say? Do you need to pay for everything? Fundamentally, yes. Obviously, this comes with some interesting dynamics, right?
Right.
If you try to kind of play it out in your head, what does it mean that I have to pay for everything? You certainly want to be paying for anything that is load bearing. Like you want to be paying for your web server. You want to be paying for some of your tools. Now, obviously, you can't have 1,000 vendors. No company likes managing 1,000 vendors. So what that probably means that at a certain extent, you need to have libraries that are big enough to deserve being something you pay for. That's also why Pavex is designed and aims to be batteries included, fully featured, exactly to kind of counter that dynamic. At the same time, you need to have some kind of mechanism which allows people to join your ecosystem. Like you don't just want an island of, I have a project that is fairly well funded and we're happy here. You also want a way to kind of scale it to other people that might want to contribute third-party plugins, third-party libraries to that ecosystem. Now, that is easier to do if the library at the root acts as a monetization funnel and then is able to somewhat distribute this, as it happens in many other marketplaces of sorts. I could quote Shopify as an example, and there are others where the platform makes money and then is allowed to also distribute some of that money to the people that make the platform compelling because they add functionality that is not available. Salesforce, I think, is another example of that. So there's interesting mechanisms that can kick in if there's enough money being captured at a certain point somewhere.
I mean, definitely. I guess some form of platforms where you pay each platform and then it gets distributed kind of makes a little more sense. I'm reminded of that XKCD of the pyramid of blocks with the, like one block for one
Nebraska.
guy. Dependency.
The guy in Nebraska. Yes, let me find it.
Yeah.
If I search SKCD Nebraska, it's gonna come out. Yes.
Yeah. But I mean, it's definitely something we have to think about because it certainly has been an issue lately with random stuff being unmaintained or having a security hole in it, and suddenly everything on the web has gone down or is hackable, or I don't know.
I mean,
solve
it's
that
interesting to
today.
have the conversation in the week after CrowdStrike, right?
Right.
That's kind of like, in that case, though, it didn't help much because people were paying through the nose for CrowdStrike. So it's not enough to pay for things for them to be good. I think that is one of the many requirements, but not self-sufficient on its own.
Personally, I like to keep my things out of the kernel. But other companies have their reasons, I suppose, for paying CrowdStrike.
I mean, I think there's a fairly complex situation where you have different incentives at all parts of this, all levels of the stack. So we'll see. Like, I'm interested in the consequences of that situation, to be absolutely fair. We'll see how things play out.
Oh, sure. I mean, it's a time of change right now for the industry for sure. So dependency injection, I spent a bunch of time writing the Leptos integration for Pavex recently. And one of the neatest things, one of the things I find most different was dependency injection. Every time you kind of write an integration for Leptos, which is basically on my end, you take whatever the request is that the server or the host is providing, you process it, you access it, you generate a page, and then you pass that off back to the web server, or the web library, whatever, and it displays it, right? But the interesting thing, at least I found for Pavex and Leptos, was that we kind of had to change the mental model a little bit, because instead of kind of that top-down structure that Axum and Actix do, Pavex kind of turns it on its head. Do you think there's going to be a little bit of cognitive friction for people who just start out using Pavex there?
Oh yeah, absolutely. I think it's a slightly different system, specifically with respect to the fact that's designed to be very explicit. This was also one of my pain points in the past with Axum, Actix, and a few others, that a lot of stuff happens outside the type system. Like, there's this handlers, there's this middlewares, but really, like, a lot of the interesting stuff is like types being passed opaquely through the extensions, and then you stuff something in the exception, and in the extensions, you take it out somewhere else, and then you put it back, and then you take it out somewhere else. There's hidden dependencies between middlewares, like this only works if there's another middleware before that puts this magic thing like inside this map, but none of this is visible in like any signature, any place, which is not a problem when you have 2, starts to be a problem when you have 10, 12, which is not at all uncommon in a fairly large backend application. Pavex instead is very different. It says anything that you need must be a function input parameter. Like, there's no secret stashes, like there's no backstage where like secret parameters gonna travel through. If your thing, if your middleware, if your request handler, if your constructor, as we'll see later, wants to use something, you need to put it in the signature. That means that it needs to be known beforehand to an extent. There's obviously some level of polymorphism allowed, but it needs to be declared. And then the framework can see it, the user can see it. And so you can look at a piece of code and absolutely understand, just without looking at the body, what are the inputs, like what feeds into this step of the processing pipeline. Which obviously requires some reworking, because the magic as the extension, any type map, has the advantage of being very flexible. So you can do a lot of black magic stuff with that. And so when you need to kind of restructure towards a system that's a lot more rigid and expects you to declare what you want to use, then yeah, you're gonna a little bit reshape things to be kind of more tree-shaped, more linear, more plain.
I mean, I know you certainly have some opinions there. I think basically, if I recall, you took the request to response types from HTTP and you removed the extensions part of it.
Yes.
And you kind of got rid of all the generics and made everything concrete. And it's definitely a nice change compared to, say, a tower service, if anyone has ever written one of those.
Like every time you look at a generic parameter, like you truly, like, especially when I'm doing Pavex, like, do I truly need it? Like, but truly, like, do I deeply need this to be there? And more often than not, if you ask yourself, the answer is maybe I don't. And this is true for, there's no extensions, response body is not generic. A lot of things are just concrete types. With the caveat, though, that they allow you to customize the way those types are built. So you do recover some, like actually a fairly high degree of customizability, like through another mechanism, which is like you can customize what goes into, you can customize how that input is produced, which is fairly powerful in a way.
For sure. Let's see. I think I'll ask one more question and we can pivot over to looking at the integration, kind of talking about some of the things that we did and some of the features of Pavex. But you are a consultant, right? A Rust consultant. That's your day job. You write primarily Rust for the web, I'm assuming.
Mostly, not necessarily just that, but primarily, yes.
How do you convince people to consider Rust for their web services, for their backend? Like what do you do to sell them on the idea of Rust on the web?
To be 100% honest, most of the times the people that come to me are already sold on the idea. They just need guidance or help or double checking what's been done. It's like, we want to do this. Is this a good plan? Or we want to do this. Can you train us? Or we've done this. Does this look good? Or we want to do this, but we need, other 5 people to do it. Can you help? So I don't do a lot of Rust pitching. Actually, my day job, not too much, but I've done it, and I do it from time to time. And usually there's various use cases. Like backend development is what I call a gray field, in the sense that for the vast majority of the applications, you can get the job done somehow. Like you can get to the finishing line with any stack. You want to use F#, you can get it done. Like you want to use Python, you can get it done. You're going to use JavaScript, you're going to get it done. There are cases where this is not true. Performance requirements are particularly strict. This rules out a bunch of stuff. This needs to run at a very high scale. It's going to be very expensive if it's inefficient. Or this needs to run on some weird type of hardware. Probably you don't want to use this thing. But for the rest, like for everything that's in this big middle, if you are convinced enough and you are persistent, you are going to get to the objective with any stack. So it's really about, is this easier or more difficult in this stack compared to this other stack? And in the things that go for Rust, obviously, there's infrastructure effectiveness is a big one. Backends that run on Rust usually don't spend a lot of compute. They may still spend a gazillion, multi-million dollars in databases and queues, but usually servers are not the big part of the spend, which is good if you're running a scaled service.
Sure.
The second part is predictability, which is a big one, actually. Rust doesn't have a garbage collector, which makes it not just fast in some cases, but mostly very boring. Like if you feed a Rust service a certain amount of work, it usually take more or less the same time. So your P50s, your P90s, your P99s will be known and stable, which makes it easy to see when stuff goes wrong, makes it easy to scale, All these things matter a lot when you're operating software, especially 24/7. Last but not least, you do have one of the most advanced type systems in mainstream programming languages. So if you're not a Haskell shop and you're picking a language from what people are actually using, you won't get a type system that's more featureful than Rust. Like, you're not getting in Java, you're not getting it in C#, you're not getting it in TypeScript, and the list goes on and on and on. Like, some types, exhaustive matches, polymorphism done with proper interfaces. Rust has all these things going for it. None of these things are novel. All these things exist in different languages.
Right.
But Rust makes it so that the language is productive, the language is fast, and the language has adoption. Like, Rust is used in the industry, which makes it so that now all these things that were niche available are now more mainstream and available. And so if you use them, it's easier to write services that are robust and in general, like, easier to maintain them. Like, that's a big sell. And perhaps not the reason then people come to Rust. It's not, maintainability is not what closes the deal on a lot of like technology decisions where people are like, I'm going to use Rust because it makes my service more maintainable. But it's a very, very common observation after perhaps the first, the second, or the third project. People are like, okay, we chose Rust for reasons, but now we're also observing that we're a lot more efficient in maintaining these services. Like, we don't need to spend as much time keeping them up to date, keeping them functional. Adding features is not as painful. You can still make it painful if you design them badly. Like, Rust is no antidote for bad software. I've seen bad Rust. It exists. There are going to be more and more bad Rust in the industry as Rust gets more popular. But if you're trying to do things the proper way, like, the compiler gives you a large toolkit to help you on the way. Now, it's up to you to pick it up or, not to misuse it, but the toolkit is there. Like, if I want to do an algebraic type in C#, I don't have the toolkit. So it's like, I'm already running with like alpha Hankel. Instead, in Rust, I do have the toolkit. And then, I can put it to use.
I think on our end, we get this question a lot too. And web dev Twitter and, the internet, the whatever, is super interested in there is one best tool for the job, you should use this or you're an idiot kind of thing, or, I need the fastest thing alive. And I do find a lot of the time that whatever you're most comfortable with is probably what you should reach for. If you are, a JS developer, if your team is all JS developers, JavaScript developers, you're probably going to have to think about that decision to switch to, say, Rust, for example, if those benefits are worth the cost. That being said, as a Leptos developer, and I'm sure as a Pavex developer, we try to make it as easily as possible for people to use it and to enjoy it and to work with it. But,
you need to be what they call on the market. What that means is you might have in front of you the best tool that has ever existed, but if you are not in a position at that point in time to pick a new tool, it doesn't matter how good it is, you're not going to use it. So you need to be in a position which is beginning of a new project, the emergence of a new set of requirements which are absolutely incompatible with your existing stack, to be even able to go out there and say, okay, what's on the menu for web dev 2024? Because if you are, in an environment where you are maintaining existing applications, so brownfield projects, the vast majority of the software that gets built, you're not picking a new framework. Like, your job is to maintain, improve, augment what's already there. Sometimes you can do some greenfield development within a brownfield environment, but then you're also constrained by compatibility with what exists. Perhaps you can do a new service, but it needs to be able to talk Corba over something that's already there. I can tell you that the Corba support in Rust is not the best. Probably Java has a much better choice. And this applies in a lot of ecosystems. Like, Kubernetes was another example. Like, if you go back 5 to 6 years ago, and you were writing a Kubernetes controller or a Kubernetes operator, there was nothing better than the Go Kubernetes client, mostly because it was co-maintained with Kubernetes. Now, today, you also have an excellent Rust client, so you could do the job, I wouldn't say as easily, but fairly easily in Rust. But 5 years ago, even though you were talking to an API over the network, so technically nothing constrained you to use Go, right? Like Kubernetes was absolutely interoperable with whatever technology you wanted to use, Perl included. It was easier, like it was a lot easier to just, lean into it and use Go. And that's how you get most of cloud native in Go, because just the activation energy was a little bit lower. And so everybody goes down that hill. And so that's the job of the designers. Like, how do I make it so that my stuff is good as an activation energy that is not unsurmountable? And then you just got to wait for people to show. And then, they complain. And then you solve those complaints, maybe. And then the next person has a slightly better time. And eventually you compound. Like, eventually you have mass. And so you try to position yourself, or you try to be the default choice for new projects. And so that graph kind of grows. I think we've seen this in the web dev ecosystem over the years, right? Like React didn't used to be React. It used to be the weird thing next to Angular. And the same applies to Angular before with jQuery and so on and so forth.
For sure. I wanted to, I'd love to keep talking about this, but I want to look at the demo and talk a little bit about some of the code that we've been writing to get here. So I'm going to try to share my screen here, and we can take a look at the stuff we've been working on all this time.
Yes.
Let's do it. Here we go. So this is the start_Pavex example that I've mostly written for Pavex. If you've seen our starters, they're not particularly interesting. It shows the Leptos logos and starter. This is a server-side rendered template, right? So you can kind of see it renders the HTML for the root as a big thing, and it populates it with data, and then we do the hydration and all the little bits of interactivity with WebAssembly here. Not particularly interesting, right? But getting to this point is always the fun part for us. So if you're interested in this, playing with this should work. We're going to get to the code in a second here. This is in the start_Pavex folder in the examples in the integration, which we showed a little while ago. Okay. So let's look at the code here. Let's see how this goes. Okay. Let's see if I can make this bigger here. If anybody remembers how to make Alacrity bigger, that'd be nice. But I'm trying. This is a workspace integration. So we've got two crates in here, the Leptos_Pavex crate and the macro crate. The macro crate's job here is primarily to take the server functions macro and give it a new request response type. So we're going to mostly ignore that one and focus on this, on the Leptos_Pavex example here. We can ignore all of the bugs, and now I should think about how to zoom in with Alacrity here.
So they say there's a font size you can tweak in your Alacrity configuration.
Control +- maybe? Let's see.
That may or may not work. Oh yeah, that works. Nice.
Is that large enough for y'all? Looks pretty decent to me from what I can see in the tiny window. Let me know if it needs to get bigger. But yeah.
I think it looks good. I'm looking at it on the stream, and it looks good.
Awesome. Okay. So if you've ever looked inside of an integration, right, we've got a whole bunch of functions. Typically, the top level is render route, for example. It takes in a list of routes, it takes in the request types, and then it returns a response. One of the things that we had to change for Pavex is that instead of this being a closure, like this used to be, that's fine, impulse function, I forget exactly what it was, something like this. It's all fixed types now. So we've created a whole bunch of new types. You've got app function for the closure that defines your app now, which actually just contains a rendered view of your app. And we return a response type, which is not rendering for me right now, but that's fine. It's the Pavex response type. I'm probably going to say that wrong a whole bunch of times, but that's okay.
It's fine. For some reason, I think it was looking for response into the manual for Vim. But that was an interesting error down there.
I get new Vim set up, and then I update it sometimes, and then it goes weird again. So I don't know. I'll fix that sometime later. But yeah, we call the render function, and then once it's rendered, you choose an SSR mode, like a way of rendering it. Sometimes you want to wait for all of your data fetching to occur before you send the HTML down. Sometimes you want to wait for something. Sometimes you don't want to wait at all. We do all of that stuff with different calls to different functions here. Render app to stream, render app to stream and replace blocks, render app to stream in order. You basically don't need to know any of this stuff unless you want to mess with the integrations or write a new integration, but I've always found it kind of interesting. Yeah. So rewriting a bunch of that. The biggest thing that I'll note here is that it is much less, as I said, much less generics, much more concrete types. Let's take a look at what that means in the example, right? Let's hop into the blueprint file. So we talked a bit about dependency injection, right? So as I understand Pavex, and you can correct me here, it's all kind of built around this idea of a blueprint file. It defines data that is constructed through some method and passed to requests. And like, how would you explain the blueprint file, Luca?
I mean, so if you go back, for example, to the function you were looking at before, where we're doing the rendering, and you show the signature. Yes. So you're basically saying to Pavex, I want this to be called, right? So this is a route for some path that we're going to see later inside the blueprint. Now, when Pavex looks at this, says, okay, I need a Pavex route list, I need a request head, a row incoming body, match path pattern, component owner, and app function. How do I get them? Fundamentally, like that's the question that needs to be answered. If you're looking at something like Axum, this would be a trade implementation. This would be an implementation of, I think, from requests or from request parts, depending on how you extract it. And so the compiler would do some lookups, and then the things would be invoked. In Pavex, instead, you need to explicitly tell the framework, when you ask for a Pavex route list, this is how you compute it. This means that we're not bound by trade signatures. You can have recursive dependency injection. So the thing that builds Pavex route list also can ask for additional inputs, which then themselves can ask for additional inputs, and so on and so forth. While the from request trade signature is fixed. And that's where the extensions come in as a way to kind of make it not fixed. In this case, for example, we have a bunch of primitive types that the framework knows how to do, like row incoming body. That's the body of the request coming from the wire. It's a bunch of bytes. You can't customize how that gets injected. You just get it. Match path pattern. That's what you get from the framework when it routes your request somewhere. So you're going to get that. Request head, same thing. That's the method and the headers and the version of the request coming in. So all of that is native. Pavex route list, though, it's custom. Like that is specific to the integration with Leptos. So Ben needs to tell Pavex, okay, when I see a Pavex route list, how do I build it? And that's where the blueprint comes in. So you go in there and say, okay, you build it with this.
Right.
Exactly.
So that was kind of the interesting bit, right? Is that is kind of setting up that whole structure. So for Pavex route list, for example, we've told the blueprint that it is a pre-built type of this type that we're going to pass in when in the server function, in the server file, right? When we run the app, and you can clone it if you need to pass to all the different requests or whatever.
Yeah, you can see it here, right? This is interesting. So on one side, we have the constructors, that this is the super long syntax where you say, okay, you're going to call this additional context components every time you need to build its return type. So it's a constructor for the output type of that function, and it is request scoped. So you're going to call this at most once for every incoming request. Then you have the pre-built types as well, which is actually anytime you're going to need some of these things, they're going to come from a type that's been instantiated for you. And that's usually configuration, other things that you would set up before launching the application. So Pavex is fairly flexible as to where types can come from. So it gives you various options, but each option has a specific use case. Like you use it in some scenarios.
Right. Ricardo asks if you use Leptos with Axum or alone. Primarily for like, if you want to do server-side rendering, you're going to be using it with some backend server. It could be Axum, it could be Actix, it could be AWS Lambda, it could be Pavex. You know, we have a lot of choices, but you need something to do that server-side rendering. And, you know, there are plenty of good servers. We don't need to rewrite one. If you're doing like client-side rendering, you kind of only use Leptos and render it to a file that's then served by a file server, but that's a little different thing. But yeah, so it was interesting to kind of figure out which things I needed to plumb in. You can see there's a little F macro for functions that we use for constructors and a little T macro for types. If I go to the, I don't know if I'm going to be able to find it.
What you looking for?
It's probably that one, I think.
Yes, that's the one.
For the pre-built types, for example, you have to pass it to, let's see, where do I pass it? It's right here to the build application state. Like we're telling the generator, because Pavex generates, you know, these functions itself when it runs. You know, we're telling it, hey, it's going to get a Leptos route. It's going to get a Leptos options or Pavex route list, whatever it is, right? And you have to pass it here or it will error. But the constructors, you don't have to pass those here. Like if I go back here, it's just going to call this for any request that wants it. And my go-to is not working, but...
So we're back to searches.
Yeah, back to the searches. Let's see, I think it's in leptos.rs here. That one. Yeah, so we've got in here, I've got a whole bunch of different, you know, constructor functions that just take in something that Pavex knows how to provide, in this case request head, returns the thing that it needs for the route, and you know, everybody's happy, right? And you know, that's a really neat thing as far as it goes. If you've done things with our integrations before, we've got a lot of like Leptos routes _ with context, so that you provide your own context kind of as a closure in line with the functions. But for this kind of thing, you kind of have to write a constructor that passes the context into all of them. It's kind of a different pattern. And it was fun to figure out. So for those of you who have written Leptos before, this integration is written for 0.7. So the not yet released officially 0.7. So you've got things like here where you generate your own shell instead of having Cargo Leptos provide that for you, which is another of the neat features in 0.7. Yeah. So let's see. Is there anything else about Pavex you want to highlight?
It's interesting. If you try to run the project, but you remove one of the constructors, I think the error messages are another thing that's worth highlighting.
Okay, sure.
So if we go back to the blueprint,
Yeah, let's do that.
we remove, for example, the first constructor.
Yeah. Let's see if I remember.
The syntax for commenting.
Well, I was gonna do it in bulk, but it's block
I know
comments
what
are a
you
little
meant,
trickier
like
in
visual
Vim.
selection, and then
I think it's like
legible.
Control V, capital I, and then anyway.
My muscle know how to do it, but like I couldn't tell you what keys I do press when I do it.
That's pretty. I think that's just what happens, right, with Vim users.
Yes.
Oh, okay. I don't know why it's being mean. Read only. Okay. Doesn't look special to me. I don't know why it's not letting me. No. Come on now. Sure. Oh, now it's running it in Vim. That's okay. Let's try that again. Go away. Maybe it'll let me edit it this time.
Let's see. I mean, it did edit it.
There we go. It did edit it. Okay. So
Okay.
now, one of the things that I haven't quite finished, I've got Pavex integrated with Cargo Leptos build, or I would if I was in the example. Let's see. But running it is a little bit tricky. But this should fail, I imagine, now that we've commented out one of the constructors that it needs to function.
Should fail for sure.
Here we go. So I really love the errors. I guess because you wrote your own dependency injection thing, you can create these really pretty error messages. You want to talk about that a little bit?
Yeah, I mean, sure. I mean, prettiness is kind of a function of the libraries we're using here. Yet does a very good job of giving you the infrastructure for each error messages, a little bit like the Rust compiler does. But the interesting thing here, like the thing I'm proud of that I think is cool, is that the error messages are very clear. Like you're not getting a compiler blurb that tells you there's this type that it doesn't implement trait that you've never seen before. Go figure out why is that. Here instead you have, okay, like there's one thing inside your application, generate app, that needs to get a component owner. Unfortunately, I have no idea how to build one. So if you want me to do this, you have potential solution. You can register a constructor, you can pass it as a pre-built, but you need to kind of explain to me how to get this component. And the idea is, the aspiration at the very least is that the error messages are good enough that you don't need the documentation, or at least you don't need to read the documentation beforehand. An improvement that I plan to make, and I keep postponing, is actually adding to each of the help messages like an hyperlink to the relevant docs. So like register a constructor for, okay, what does it mean to register a constructor? Link to the guide. Alternatively, use a pre-built. What's a pre-built? Link to the guide. Because the guide as well, I think is pretty cool if you open that. A lot of my hours, little hours, have gone into that. So on pavex.dev, you can find the docs. And the docs are extensive. Anything you can think of that Pavex does, there's going to be a doc page. It's going to explain how to do things. There's going to be examples. There's annotations. I try to make it the docs I would like to have when I was building something. All of these things link to each other. The link to the API reference, which is also there. So it's part of the framework, I think, without questions. Like, I think good docs, good guides, they go beyond just an API reference, are important when using tools.
I mean, I've been using this for a while, and I've kind of seen you develop these docs from almost nothing to this structure, and I mean, it's been lovely, reading these now and seeing how everything mostly works. And good docs are so underrated for frameworks and stuff these days.
I mean, it was nice when you were doing the integration. You were like, "How do I do this?" And I was like, "Here's a doc." And like, it's good when you have those, and like, okay, it means I'm writing the right documentation.
For sure. David asks if your error messages were crafted using Miet.
Yes, they were. So if you go on the Pavex repository on GitHub, and you go into the libs folder, you'll find a crate called Pavex_Miet. Oh yeah, do it for me, please, Ben. Libs Pavex Miet. And in there, you can see the renderer that we use for Miet, because we had to do a bunch of customization to show multiple snippets and other things. But other than that, yes, it's just Miet. It's me forking one of the renderers to do some tweaks and put things in colors that I like better. But other than that, all the heavy lifting is done by Miet. Plus, obviously, like, it's not like you can just plug a library and get nice errors. You got to keep track of where is this function defined, where was this constructor registered. So there's a lot of code inside Pavex CCLI, so the actual Pavex transpiler, that keeps tracks of all the things. Like, I can go from a constructor to random span in source code. Like that is the infrastructure you need.
Yeah. Lots of fun stuff in here, and I could spend a lot of time like asking you questions and digging through this, but I want to take the opportunity to ask, to give people an opportunity to ask questions. But before I do that, if people are interested in trying out Pavex, we've already talked about the Leptos Pavex integration is public. It's on that GitHub page that we've linked to before. You know, you can copy the example and modify it. But for Pavex in general, if people are interested, what should we do?
So you should go on the Pavex.dev website. There's a little link that says early access, I think. Yeah, it says early access. I was going to ask you a few questions, mostly to understand who you are, in the sense of why are you looking at the web page of a Rust web framework? Are you a Rust developer that's used a bunch of other web frameworks? Are you a Python developer that's looking into Rust? What's your background? And this helps me understand what kind of people are interested into this, as well as give you support. At a certain point, you receive an email, which gives you access to a Discord server. And then from there, you'll be able to basically use everything. I haven't been sending a lot of emails recently, mostly because waiting for a first kid and renovating the house and moving. So that's been a lot. But now things are quieting down slightly. So I expect to send out a new batch of invites probably next week or the week afterwards, after I've done a bunch of bug fixing. So you'll get a nice experience. But this is the process. At a certain point, we'll go open beta, at which point you'll won't have to wait for an email. You just sign up and start using it, and eventually we go GA. This is how it works.
I mean,
but the docs are public, so you can browse the docs without being part of the beta.
Oh, totally. You heard it here, guys. If you're interested in Pavex, sign up here and read the docs and look at the GitHub and try it out, right? Yes. I think we'll transition to a Q&A kind of time. If anyone has any questions they'd like to ask Luca or me, feel free to drop them in the chat, and we'll answer them. Okay, so a question from Danny XX. Greg mentioned in the release description that you have plans to integrate native UI tools. This means really native, or do you like Skia and other frameworks? So for 0.7, we have created a new set of traits that basically combines the DOM with almost any kind of rendering engine. So we can do like GTK, for example. We can already do Tari, which is not native. We can do Rye was making the rounds a little while ago. But basically, you can do almost any kind of framework that you can implement the traits for, which is mostly like how do you render a DOM node and how do you render text and those kinds of things. If you've used Axis before, they've got their own little thing that's a native renderer's name I can't remember. And they're much farther along than we are, but we're certainly exploring that in 0.7. Okay. I'll ask one. So you mentioned open beta, right? Do you have a timeline for that or release? Are you like rushing for something, or like,
Friends don't ask other friends by what time they're done with a software project. But I'm trying to get it out by the end of the summer, ideally mid-September, worst case scenario. I have a few milestones for beta. Mostly it's what I call, in Italian, but not in English. When you're writing a compiler and then there's the milestone where the compiler can compile itself.
Sure.
So in my case, what I'm writing is the Pavex admin dashboard for managing your subscriptions and a bunch of other stuff. And obviously I'm writing that with Pavex, which means I need a bunch of things, some of which are available, some of which are not, like sessions, for example, cookies, various kinds of social logins and things. And so once I get that done, so once I build the dashboard with Pavex, that means two things. A, I have the dashboard I need to go open beta. And B, Pavex is good enough to write a website that's non-trivial. And at that point, I've fixed a lot of the bugs, and I think it's good enough for people to try it out more generally. I'm not writing the UI with Leptos. I'm writing that with HTMX, mostly because I'm a guy that used to do UI with tables in the early 2000s. But that's the principle. Like if Pavex is able to host a somewhat interactive backend and do most of the things and do them securely and do them nicely, then it's good for people to try it out. Like the reason why we did a closed beta was precisely not to put like an MVP, as people say, in the hands of people, and then the MVP is super broken. It's like, you want to try something that's broken or somewhat broken, come to the private beta, we'll hash it out. By the time I say, this is good to try it out, it'll meet a level of quality where you're bound to have at least a good time. And then you may still choose to use something else.
Ricardo says that you should include it in the next update of Zero to Production in Rust. Are you planning on
different philosophies? Like Zero to Production is meant to be for people that want to go to production. And so by definition, you don't use a framework that's embedded. Eventually, if things go well, everything plays out beautifully, the next edition might be using Pavex. But for the time being, I think it's going to stay at XWeb.
Zero to Production in Rust 2 Pavex edition.
Yes.
I'd do that for sure. I mean, that's great. It's really been fun talking about this, and I'm looking forward to getting more eyes and hands on the integration and on Pavex in general. Doesn't look like we have any more questions, and we're a little over 1 o'clock here, so we can probably wrap it up. Kind of a summary, right? Check out the Leptos 0.7 beta we've put out. Tell us all the bugs we have. We'd love to have you guys next month. We'll be, I think it's the third Saturday every month. And yeah, if anyone
last Saturday of every
jump
month
in here over there.
Yeah, last Saturday of every month. So the next one is August 31st.
Awesome. Thanks for coming on, Luca. We'd love to have you.
My pleasure.
Thank you for joining, Luca. It was awesome. Super interesting.
Thank you very much.
All right. Then, till next time, everybody. We'll see you in Discord.
Sounds good.
Bye.
Bye-bye.
Bye.